term penambic actually has a history in artificial intelligence because there's a history of basically fraud and deception and hoaxes in artificial intelligence, where people have created programs which weren't really intelligent programs. There was a man behind the curtain controlling the output somehow. So originally I called my program penambic, but it was already running on a machine. It was running on a machine that was already named Alice. So people started calling her Alice. and then I came up with a retronym for Alice, which was Artificial Linguistic Internet Computer Entity. Once I began working on the Alice program, I decided to, I basically found that I was repeating the same piece of code over and over again. And that code is basically, if the person says this, then say that. And because I was repeating the same thing over and over again, I wanted to create a simpler way of formatting that information. So I devised this language, AIML, Artificial Intelligence Markup Language, to format that information. AIML is influenced also by the web, by HTML, because they're basically the same format. And I wanted it to be a very minimalistic, simple, easy-to-learn language so that somebody knows a little bit about HTML and I'll teach them how to write in AIML also. About 1998 or 1999, I wanted to distribute this program more widely, and I had the good fortune to almost accidentally select the GNU public license as the software license for the first versions of the Alice program. That's the same license as Linux.
Oh.
Probably most of you may have heard of Linux. Basically, the story with Linux is that no company or group of companies can compete with Microsoft in operating systems. But a worldwide federation of volunteers donating their time freely can compete with Microsoft. So I tried to apply the same model to the development of this artificial intelligence. And we did that basically in three ways. We released the specification for the AIML language as an open standard. And then we released a program written in Java that could implement this AIML. And then the third thing, which was the most important thing, was we released all of the contents of the Alice brain, all of these input-response rules as free software. Subsequently, in the last decade, there's been a fairly substantial effort by a large number of people to add to this body of work. And people have taken the AIML standard and written their own programs, some of them free software, some of them proprietary, to run the AIML code. And those are written in all different languages. So if you look around, you can find Python, Perl, PHP, Java, C, C++. Basically any computer language you can think of, someone has written an AIML interpreter in it. And people have also added to the body of the knowledge base that goes into Alice. The original ELIZA program had about 200 inputs and responses. And in AIML, we call those things categories. Currently, the Alice program has about 150,000. So it's 150,000 compared to the 200 of the original ELIZA program. And I always like to say that most conversation, most typical average chit-chat type conversation between people is statements. And what I mean by that is that if I'm having a conversation with you, what I'm saying to you right now depends only on what you just said to me, and we can forget the whole history of our conversation up to this point. Sometimes you notice that when you're talking to someone because you'll say something like, "Where did you go to school?" And they'll say, "I told you already, it was Cambridge." "Oh, I forgot I asked you that question already." The main time when state comes into play in conversations is when we're responding to questions. Because if your input to me is yes, then I better remember what the question was that I asked you that made you say yes. So I can put that together with your yes and come up with a coherent response. apart from those situations, most of the time, conversation is stateless, which means you can create these behaviorist rules, these behaviorist stimulus response rules to simulate a natural conversation. So with all of that, with the ELIZA-style stimulus response architecture, the AIML language, the community of free software volunteers contributing to the effort, the ALICE program was able to win the Loebner Prize in the year 2000, which actually I'm most proud of, because if you look back in Turing's original paper, he predicts that within 50 years, when memory reaches the size of 10 to the 9th, which is incredibly prescient, that he would realize that around 2,000 computers would have about 1 megabyte of memory, that a computer program would be able to play his imitation game. And although my program may not be as performing as well as what Turing has envisioned, because he made this 50-year prediction in 1950, I think historians will always look back to see what happened in the year 2000 in the Loebner contest. And then the ALICE program won the contest in 2001 and in 2004.
So, if you wanted to run that Turing test on the program, based on what you just said, the way to determine which one is the computer and which one is the human being would now be which one doesn't forget the questions you've already asked it.
Yes. Well,
so if you could ask it enough questions, the human would screw up and forget something.
The sharper one would be the computer.
Generally, one of the criticisms of this test, and by the way, the Loebner contest has just been a magnet for controversy in many dimensions ever since it was founded. But one of the criticisms has been that the judges know they're trying to out the robot, so they ask very aggressive style questions that people normally wouldn't even respond to. Like they'll say, which is better, a 747? Which is bigger, a 747 or my big toe? If you just kind of introduced yourself to someone and asked them that question, they probably wouldn't even talk to you. But they expect the AI to be able to answer this question.
Because it would be compelled. It wouldn't realize socially that was a stupid question and to move on.
The program, it depends on the program. Different programs will respond to it differently.
But most people wouldn't say, what?
Most people would ask, why are you asking?
But could the program actually say, what?
Yes.
What is it that you just asked?
Yeah.
Because that would be the normal response. I'm sorry, maybe I didn't hear you right.
Yeah.
So your ALICE program could indeed respond in that appropriate way.
Or it could elect.
Although, what ends up happening is that there are so many default cases. Like I showed you the example in the ELIZA program where the beginning of the sentence was, I like something. Now, if the program is going to respond every time to something like that by saying, I didn't understand you, then it doesn't sound very intelligent. It's almost like talking to someone on a cell phone when you've got bad reception, and you hear them say, I like. Okay, how are you going to respond to that? You're going to say, I didn't hear you. Could you repeat that? Or are you going to try to come up with a clever response that keeps the conversation going smoothly, kind of pretending that you heard what they said?
Well, because your program's just got a set way of thinking and responding, it doesn't have common sense, so it couldn't answer those kind of questions.
Yeah, I see. I don't know. This is supposed to be an hour talk.
Hour.
How did your program respond to this whole question? How did your program respond to a question like that? What's bigger, a 747 or my big toe?
Right now, what it does is it picks one randomly.
Oh, okay.
Number of letters and stuff.
Right, something like that. So half the time it will say 747, half the time it will say my big toe. But even if it says my big toe, your big toe, then it's still an intelligent sounding response.